Here we're going to be training an AI model to recognize images, custom images in our custom dataset. So in the last video we used the MNIST that was imported by the TensorFlow library. In this video we're going to make our own custom dataset and we're going to use it to identify images. So let's do it. So the first thing you gotta do is in your project directory you're gonna in your project directory you're gonna make another directory in your directory called subfolders. Now in this subfolder you're gonna have two other or how many ever subfolders you want or how many ever directories you want. In this case mine says house and the other one says windmill. There was supposed to be house and windmill, but that was just too complex for my model. So I'm just gonna click on house for instance, and you can see like I've labeled house from house underscore one dot png. It's all the way up to house underscore 60 dot png, and then it's the same thing for the windmill. So how we're gonna do it here is, so the image labels are going to be the same thing as the directories you get them from. That's why we named this directory house, and then the other one is windmill. So yeah. So it's going to be the same thing that your directories are called. So this is a training, as you can see here, image classifier custom training.py. So to train it, we're going to first import OS. Then we're going to say os.environ. Then we're going to pass a string. We're going to pass a string here. We're going to say in all caps tf underscore cpp underscore log underscore level. Okay, and then we're gonna say that equals 2. So we're gonna say import os.environ and then a string tf cpp log min. So there should be a min here. Min log level is equal to no, it should just be equal to is equal to 2. Then we say import tensorflow stf. Then from tensorflow import keras. tensorflow import keras. No. Keras. Bro. Keras. Then we say from tensorflow. No, not tabulate. tensorflow. From tensorflow dot keras import layers. Then from tensorflow dot keras dot preprocessing dot image import image data generator. And then this is the last import numpy as np. So this image data generator is just to augment the data, so it makes our model more robust, if you will. So we're going to specify the image width. This is based on your training images. So like what do you want it to be about? like say I have like 32 by 32 pixels image for training, so you have to say image width is 32, the width of your training image basically. And then you say image height is equal to 100. So actually my image is 100 by 100 pixels. Then we're gonna say batch size now since I've only I've only made like 60 files, folders or images, whatever you wanna call them. I showed you. I'm just gonna say 32 for now. And then we're gonna set the data augmentation configuration. So we're gonna say data gen is equal to, we're just gonna say image data generator. And we're gonna say, you can mess around with these values, but this is just what I do. So rotation is equal to 30, and then width is equal to 0.1. No, it's not width, it's width shift range. Width underscore shift underscore range is equal to that. Then we say height underscore shift underscore range is equal to 0.1. shear range is equal to 0.2. zoom range, so this will tell us like randomly it can zoom at this, the maximum is this range, so zoom range is 0.2 again. Horizontal flip underscore flip is equal to true, so it can randomly flip the images. And then fill mode is equal to nearest, so that's a string, nearest. And then you obviously gotta close the brackets. Now that we did that, we're gonna specify our model architecture. So we're gonna say model equals keras dot sequential. And then we're gonna say model dot add, and we're gonna say layers dot max pooling 2D. So layers dot max pooling 2D, and we're gonna say the filter size is 2,2, and then the input shape is wait a minute, did I add an extra? I think I added no, I didn't. Yeah, I did. So 100 by 101. So in this case, like it's 100 by 100 pixels, which actually you can specify image width and height. So image width, image height, and then this is the amount of colors. So you only have black and white in this case. So 1. Then we're gonna say model dot add. We're gonna add a convolutional layer this time. So con 2D, and then we're gonna say 16 filters. 16. filters which are 3 by 3. Then we're going to say activation, nope, is equal to ReLU. Then we're gonna just do the same thing. Actually, we can just control G. So this time we're gonna have 64 filters, 64, and then this one's gonna have 128. So next we're gonna say model dot add, which is gonna say layers dot max pooling. The same thing here. Same thing that we did here. It's basically the same thing. Max pooling 2D. Then the filter size, or I don't know what this is basically. It's gonna be 2 by 2. Okay. Then we're gonna say model dot add. We're gonna add layers. We're not gonna add a flattened layer. We're gonna add a dropout layer. Dropout, so our model doesn't overfit. And then it's gonna have a dropout rate of 0.29. Then model dot add layers dot. This time it's gonna be a flatten, so flatten. And then we're again gonna say model dot add. Nope. Bro. Model dot add. We're gonna add layers dot dense. Gonna add a dense layer. And this layer is gonna have 128 neurons, so 128. And then the activation is gonna be ReLU. So activation is equal to ReLU. And then model dot add the last layer, layers dot dense. And the amount of neurons for this layer depends on how many categories you have in your custom dataset. I have 2, so it's gonna have 2 neurons, and the activation is gonna be softmax, not ReLU, but softmax. Softmax. Nope, that's not how you spell softmax. Then we're gonna say ds underscore train is equal to tf dot keras dot pre-processing dot image data set from directory. Image underscore data set underscore from underscore directory. And then we're gonna pass in. So our directory is subfolders. Do you remember I said subfolders? Subfolders. You can name it anything you want. It's those folders inside this that the name matters. So it's gonna say labels is equal to inferred, which means we have inferred the labels in the directory names. Then label mode is equal to int. Then we're gonna say class names is equal to actually I forgot to rename these files here. I showed you it should be house and windmill, but actually I've made rectangles and circles, so I forgot to rename it. But we just pass in these 2 folders here, whatever you've named them. So for mine it's house and windmill. Next we're gonna say color mode. Color mode is equal to grayscale. So gray with a, not grey, grayscale. And then we're gonna say batch size. Batch size is equal to batch size that we defined up here. Batch size. And then we're gonna say image size. Image underscore size is equal to, we're gonna pass in image height and image width. Next we're gonna say shuffle is equal to true. So basically we're saying that it can shuffle all of our data. Then we're gonna provide a seed that's gonna be 1 to 3, whatever you want to call it. And then the validation split is gonna be 0.1. The validation split is 0.1. Then we're gonna say subset. Subset is equal to training. Nope. Alright. String training. I think that's all. Nope. Preprocessing. And then we're just gonna copy paste this. So Control C, Control V. But this time we're gonna name it DS validation. DS validation. And then this is not gonna be training, this is gonna say validation. Then we're gonna compile the model. So we say model.compile. And then the optimizer is gonna be Adam. The loss is gonna be sparse, categorical, categorical cross entropy sparse categorical cross entropy. And then the metrics we want is just gonna be accuracy. And we're gonna say we're gonna say, hold up, yeah, we're gonna say train images, train underscore images. Then we're gonna make that a list, but we're not gonna pass anything. Then we're gonna say train labels, train underscore labels is also gonna be a list with nothing in it. Then we're gonna say for images, comma labels in ds train dot prefetch in ds train dot prefetch df dot data dot experimental dot data dot experimental dot auto tune. Then we're gonna give semicolon obviously because it's a for loop. We're gonna say train images dot append. So we're gonna append. We're gonna say images dot numpy. Images dot numpy. Then we're just gonna control D. Okay, no. There should be dot. We're gonna make this train labels dot append labels no dot numpy. So we're gonna say train images dot np equals train images equals np dot concatenate, if I can spell it, concatenate. We're gonna concatenate train images, and then we're just gonna control T. Then we're gonna say train labels equals np dot concatenate train labels, and then we're gonna say now we're gonna fit the model. So history is equal to model dot fit. So we're gonna say data gen that we defined up here, all the way up here, data gen. Then inside of data gen we're gonna say data gen dot flow. Then inside of that we're gonna put brackets. Then inside of those brackets we're gonna say train images comma train labels, and then we're gonna say batch size is equal to batch size. Then we're gonna say epochs. So how many epochs we want? Consider to 30. Then we're gonna say validation data is equal to ds validation. And then after it trains, we're just gonna save the model with model dot save, and then you can save it to whatever you want. I'm gonna save it to test dot model, and then that's it. So you just gotta run this, and then wait for like 15 like 30 seconds, and then it'll train the model. I've already done this, which is why you can see I have test.model here. So I've already done it. So then once it's saved, or once you run the script, you can go to, in my case it's test.py, and then we're just gonna say import. This is to use the actual model, tensorflow as tf from tensorflow dot keras dot models import load model. Then we're gonna say import cv2, import numpy as np. Then that's all our dependencies. We're gonna say image is equal to cv2.imread subfolders, and then you can give like you have how many ever folders you have in this subfolders. I have 2, so you can give any one of these, any one of the directories in subfolders. So I'm just gonna give like for example windmill, and then I'm just gonna give it a random windmill image. So we're gonna say windmill, we'll just say 10.png. Then we're gonna say cv2 dot in caps I am read grayscale. So nope, I am read grayscale, cv2.im read grayscale. Then we're gonna say resize, or actually we don't need to say that. If your images are the proper length, then you don't need to say that. So we're going to say processed image process underscore img is equal to resize, which is just going to say actually this is image dot as type image. Oh wait, as type gonna pass in float 32. Then let's say divided by 255.0, and that's not how you spell processed. Then we're gonna say processed image. We're gonna expand the dimensions here, equals np dot expand dims processed image, and then we're gonna say axis equals 0 for this case, and then we're gonna control this. This time we're just gonna say axis equals 1. Okay, there. This time now we're gonna say, now we're gonna load the model. So model equals load model test dot model. So whatever you saved your model as, you can use it. So yeah, and then we're gonna make a prediction now. Prediction is equal to model dot predict processed image. We're gonna give it processed image. Then we're gonna say prediction is equal to np dot argmax prediction. Then we're gonna say if prediction is greater than 0.2, then we're gonna print, it's a square in this case. You can print whatever you drew. It's handwritten, so it's currently recognizing handwritten digits. So else, that's not a spell, else print circle. So that's it. What did I do wrong? What did I do wrong? Eh? Seriously, what did? Oh, here. Okay. So we're gonna just run this. So now let's see. So we specified windmill 10. So let's go to windmill 10.png. As you can see, it's a square or rectangle, whatever you want to call it. So now we're gonna run this. So it has never, like, it doesn't have the labels in this case. It only had the labels in the training. So it's gonna predict and it's gonna tell us what it thinks it is. So when you import TensorFlow, it has to load all the code. Sequential is incompatible with layer. Hold on. What? What's the error? Where's the line number, dude? 70. There is no line 70, dude. Line 15. 15. I think we have to say it's a numpy array. I think. I don't know. Let's just try np dot array. np dot array. Done. That. So now let's try. I don't know if it's gonna work. Hopefully it does. Not compatible. So let's see here. cv2.imread. Okay. .imread grayscale process image. Wait. Yeah. Process image equals resize. No. Process image equals resize image. No. Process image equals image dot as type float 32 divided by 255.0. Then we're gonna say processed image equals np dot expand dims process image, and then the axis is 0, and then the same thing. Oh, -1. I think now it should work. How do you even? Yep, see, it works. It's telling us it's a square, and as you can see, it's a square. So yeah, actually my model got 100% correct in while validation while I was training it. So I'm pretty sure yours is also gonna get somewhere close to that. So that's it for today. So okay, bye.